So I give you homework and I grade it not for correctness, but for doing it. If you do your homework and it is not correct, that's not the problem when I'm grading. The problem when I'm grading is to check that you have actually done it. I look for evidence that you did it. The main evidence for me is that you are writing an answer, not just saying a word. If I ask you, what is the color of your eye? And you just say blue, I will not consider that you did the homework. Because for that, if you go through at the back of the book, you will see blue. The answer is at the back of your book. Okay, all the answers to the homework. So that's not what I'm looking for. What I'm expecting you to say is that the color of my eye is blue. My eye color is blue. A statement that shows that at least you thought about it. Otherwise, there's no way I can know that you did it. If I say, what is the average age of students in this class? And you say it is 10. The average age of student in this class is 10. That's, you get the full mark, even if it is not true. But you want to read the question and attempt to answer. The purpose of the homework is not to check what you know, but what you don't know. It is through the homework that you know what you don't know. The beginning of knowledge is the knowledge of what you don't know. Sometimes you think that you know, but you don't know. You know, somebody says something, sometimes you hear something else, right? I can say something, but what gets into you is another thing. How do you know? Unless you confront me again and say, that's not what I said. What did you say? I say it again. At that time, you can even detect why you got it wrongly. So that's the purpose of homework, is to check what I say. Is that what you know? If you don't do it, you will not know that you did not get me well. Okay? So that is the purpose of homework. And I mean, for this class, that you do it, and then if you look at the back of the book, the answer is not, your answer is not correct. You come to my office. You send me an email. If I can answer it by email, that's fine. Sometimes I can even say, okay, let's meet up on Zoom. You will see that there is a link on Zoom for every day. There is a link on Zoom. It is because if I tell you, let's meet on Zoom at 7 p.m., sometimes I receive an email at 7 p.m. and they say, are you available in 5 minutes? If you are available, we just go to Zoom, 10 minutes, we are done. I can send you a long explanation on email, you read and you cannot understand. But from past experience, when we are talking on Zoom, it's so fast. Sometimes I will ask you, show me your calculator, what are you getting? And you can show me and I can see, and I can understand what you are doing wrong, and I will explain to you. So that's why you see, it is the same time, but at any time on the day, we can use that link. So don't just look at that time on the Zoom link. I don't like the fact that we cannot see this. If you have your computer and you want to see what I'm saying, you can connect on Zoom. Because I will tell them this is not, oh, maybe it's here. So homework is 2 points for each chapter, and there are 10 chapters, total of 20 points for homework out of 400. There is a total of 20 points out of 400. Then there will be take-home problems. Take-home problems are problems that are set the way your exam is going to be. Those ones, I grade them for correctness. It carries 5 points. And generally, it is about 2 to 3 questions. would really like that we all see them. Good. Now it's good. Okay, now we can now look at the board. So we have take-home problems. I'm going to show you the take-home problem 1. So let me get into the students view. So this is what you will get. I'll go to module. You have the Zoom link here. You click there and then you click the day. And you are with me on that day. Just identify the day. This is the link for office hour. You click here. If it is Tuesday, Thursday between 12:15 and 1:15, you click office hour. So this chapter 1 audio is the PowerPoint. You can go over it. It's a recorded PowerPoint, which can help you before, you can go over it before class. Now, chapter 1 homework here, because most of the time you are not yet having your textbook on the first week or 2, I put the chapter 1 homework here. You click on this, you will get the chapter 1 problems. So you shouldn't tell me that you cannot do your homework because you don't have the textbook. The homework are here. So then, back to module. Take home problem 1 is due on January 26th, the same day as the homework. So this is the take home problem 1. So you have about 3 questions here. You have to answer this for take home problem 1. Exam question will be anything on chapter 1 will be like what you are seeing here. That's the purpose of the take home problem. It's like a preview for the exam. So the Tuesday before the class, we go over all those take home problems. Most of the days, the time the take home and homework are due at midnight, but I give it until maybe the next day for those who will submit late and afford to lose some points for submitting late. That is another. So when you submit late, I know you are late, I subtract 10%. If you request more extension, then 10% every day. After 10 days, all the points are gone. So no need to ask me, you want to submit for partial points. So take-home problems are graded for correctness. Most, at the end of today, you should be able to do the take-home problem 1. But do your homework, because as I will be doing chapter 1, you will see that I can't tell you everything that you need to know. That is how it is with statistics. It's through homework that you will learn more. When you don't do homework, I assume you have done, because knowledge in mathematics is completed through your work. Mathematics is like sport. Somebody can tell you how to kick the ball, but if you don't try to kick that ball, you will not know what it is. If you don't do the homework, you will not know what it is. You will just be feeling like you know, and you will be angry why you got it wrong. But you are right, but that doesn't give you those points right. Okay, so do the homework every day. If you have a question, I will be always willing to help you. Take-home problem is graded out of 5 points, and there are 10 of them making 50 points. If you have trouble doing your take-home problem, contact me. I don't discuss it in class. You come to my office, we will do it together. I will help you to do it. You contact me on Zoom, I will help you to do it. But not that you have to take the class time to do the take-home problem. It is to be done at home. Exam is done also in class. Exam is done in class, like the take-home. That is, you will type it. Unless you don't like typing it, you will try with your take-home problems. And on Tuesday, before the exam, which is on Thursday, I will ask you if you would like to use paper to write it on paper. If you prefer to write it on paper, you will write it on paper. But you will compare whether it's faster typing. The advantage of typing is that you already have the Word document and you just complete. But when you are writing, you might have to write more. But I tell you, some students prefer writing and they write faster than when they are typing. I will write faster than when I'm typing. But most of the time it's easier to type because you can copy sometimes and paste from the problems that are there. So this is about take-home problems, which is 5 points for each of them. You will see, for example, that take-home problem 3. Take-home problem 3 will be due at 11 a.m. This is because I'm teaching another class at 11 a.m. So you have to be careful about that one. Just put in mind that you should be ready by Monday night, every Tuesday. It is because I have to go over it in that class and in this class for the exam that is on Thursday. Okay. As I said, just let me know what time I'm available. You cannot come to the office so that we have a meeting on Zoom. Do a take-home problem doesn't take 20 minutes when you are doing it with me. Sometimes just 10 minutes because you know already much, but there are some aspects you don't know. So don't wait until I grade it and you are feeling like you didn't get the full marks. So you will have 3 exams. The first exam will be on chapter 1, 2, and 3. The second exam on 4, 5, and 6. And the final exam on 7, 8, 9, and 10. So each exam is 100 points. So the total gives us 400 points, and the grade distribution is here. So here are the due dates for take-home problems and homework for each chapter. And the homework are also here, they are on Canvas. So, any questions so far? So, if there is no question, we will start with chapter 1. Chapter 1 is the introductory chapter. One is statistics. So statistics is a science, a study of how to collect information. How do you get information from people? People can be anything. It could be schools, it could be trees, it could be humans or whatever. Even viruses like COVID-19. So we call it generally data in statistics. So we learn how to collect, organize, summarize. We summarize by computing some measures like the average or variance, standard deviation. Presenting data using graph, analyzing it to make predictions or draw conclusions. So the main object in a statistical study is an individual from whom we get that information that we call data. And the collection of all those individuals in a study is called a population. Like the population of the United States, like the population of St. Francis. Any portion of that population is called a sample. And the information that we collect from each individual in our sample is called data. You don't need to memorize all those. As you go through, as you see who you are, you will remember, because there are things that you know. I'm just putting it together. So there are two branches of statistics. If you have a question, what are the two branches of statistics? We have descriptive and inferential. Descriptive is describing what you have. Inferential is the inference you make about what you have. So descriptive statistics consists of collecting, organizing, summarizing, and presenting data using graphs. That will consist of our chapter 1, 2, and 3. Inferential statistics analyzes data collected in order to make predictions or draw conclusions. So we may want to know the average age of St. Francis University students. We have to take a sample and then collect data from the sample. Compute the average that we have and use it to make inference about the average age of St. Francis University students should be about 19, for example. Oh, by the way, there is something I skipped, is the project. There will be two projects in this class. So the first project is at the end of descriptive statistics. You will collect data, you will organize it, we are going to learn it, and then you will summarize it and present it onto a graph. For that project, you will put yourself into a group of 2 to 4 students. So you should start thinking about who you want to work with and let me know, maybe before next weekend. Let's say before next weekend, as soon as possible, because I will form groups. What, let me say by February 1st. By February 1st, you should tell me which group you want, who you want to work with. If you don't find somebody, I will randomly put you in a group. I'll put you in a group and then you will try to know who you are working with. So you need to be in a group and submit your project as a group. Always submit your project as a group. So this is, the first project is on descriptive statistics and the second project is on inferential statistics. So any measure that we get from a population is called a parameter. And a measure obtained from a sample is called a statistic. If we are thinking about the average age of St. Francis University students, we will need something that we may not know. If we can get it, it is a parameter. If I take this class as a sample and take the average age of individuals in this class, it will be a statistic. We use statistics to make inference about parameter. For example, I might have a pen like this, or a coin. Let's think about a coin. And you don't know whether that coin is fair or not. Assume you have a coin, an Arctic coin, and you don't know whether it's fair or not. And you assume that if a coin is fair, when you toss it, you should get half head or tail, 50%. That 50% is a parameter. It is always like that. It does not change, but we may not know it. We may not know it just as much as we don't know what the weather is going to be tomorrow. Okay. But we can decide to toss that coin 20 times, and that is a sample of values we are going to get. And we take the proportion of head from that 20 times is a statistic. It can be used to make inference about a parameter. If I toss my coin and get 11 heads, I will say that, okay, the proportion of heads is about 11 over 20. It's about that. It's close to that. This is an inference. And we only make inferences about parameters because we don't know them exactly. In the course of statistics, we learn how to find those values from which we are going to make inferences about the population, about the parameter which is unknown. What will be the cost of the stock, the stock market tomorrow, for example, or 10 days to come? We use the past experience as our sample and we make a projection about it later. For example, we might be interested in studying apples produced in Pennsylvania. Do you think it's possible to account for all the apples produced in Pennsylvania? No, it is not. We will need a sample. So we are going to learn how to get a sample that is representative of all the apples. If I go to Walmart and see a basket of 1,000 apples and buy it all, do you think that 1,000 apples could be a good representation of apples produced in Pennsylvania? No. Even just at Walmart, you can see like 5 types of apples. You might decide that if I want to study and take 50 of each of them, I will take 10. So we are going to learn those sampling strategies in order to obtain a sample that is representative of the population. So the information that we collect from each apple is what we call data. What do you want to study from the apple? Do you want to study the size? Do you want to study the taste? Do you want to work on the color? Do you want to work on the location where they get more apples, for example? Each of those are what we are calling variables, data, information. They are not the same for all individuals. They vary from individual to individuals, and we call it variables. In that sense, there are 2 types of variables. Variables that are quantities. If I measure the size, maybe the diameter of each apple, I will get a number. That number is a quantitative value. So when data are expressed as numbers, we call them quantitative variables. So if you could remember what was on the take-home problem, and at your homework, you will be given variables, and you will have to decide whether it's quantitative or not. When it is not quantitative, we call it qualitative. Qualitative like color, like the taste. It is good, it is very good, it's excellent, it is bad. So that is quality. Color, for example, is red, it's green, it's yellow. These are qualities. The distinction between quality and quantity is that when we are dealing with quantity, we can add, and it is meaningful. If the diameter is 5, maybe 2 inches, if you take 2, it will become 4, and it makes sense. But sometimes you may have numbers that are not quantities. For example, your zip codes. Zip code. Is it a quantity? 15940. If we subtract 10 from it, do we get the zip code of the next city? Subtracting or adding doesn't make sense, right? They are like just name of cities, which we are using numbers for. Like we say January 1, February 2, March 3. Do we get March by adding January to February? February is 2, January is 1. Which of the 2 is bigger? Does that make sense to be thinking about bigger in terms of those 1, 2, 3, 4? So those numbers, even though they are numbers, they are not quantities. They are actually qualities. So when we have variables, we can again characterize them in terms of their level of measurement. The lowest level of measurement is the nominal level. At the nominal level, the variable is referred to only in terms of its name, and no other can be put into those variables. For example, color. green, yellow, blue. Can we arrange them in order? There is no order in color. Student's name. You can use alphabetical order, but that's not what I mean by order. Order is in terms of values here. Now, if you take apples size and you say small, medium, large, these are qualities. So this is more than nominal. So at the nominal level, we cannot order. At the nominal level, there is no order, only name. For example, zip code is at the nominal because you can't order zip code, can you? Loreto zip code is 15940. Is it bigger than what city? It's smaller than it, Altoona zip code. Do we reason like that sometimes? No, you don't order zip code, so it's nominal. When your variable can be ordered, we call it ordinal. I didn't touch anything. Look at where I'm standing. So when the variable can be ordered, we call it ordinal. Because it can be ordered but can add and subtract. At the ordinal level, the most you can do with it is ordering it. Nominal level, the most you can do is naming it. Like apple size, medium, large, small. You can order it. But if you measure the diameter of an apple and you get values, numbers, that size in terms of number is no more ordinal because you can add the size in terms of numbers and subtract something, add or multiply, and you get to the next level, which is interval. Interval, at the interval level, you are dealing now with quantitative values. And we call it interval because it is only a range of values. What time is it now, for example? Anybody tell us the time? 1:52. You can read it here. 1:52, right? If you look there, what will be the time? I can read something else, you read something else, somebody read something else. Do you understand what I'm saying here? So, what time is it again? 1:52. We are still saying 1:52, but it is not the same time, right? Sometimes has elapsed, and we are still saying 1:52. So 1:52 is a range of values. Normally, we are already above 1:52. Sometimes you might see it at 1:53, and some other clock is still having 1:52. So in an interval level, the number we get is a representation of the range of values. We get 1:52 is already 1:53. So, but we will spend some time and it will still be saying 1:53, but it's not going to be exactly the same time because we know that some minutes, some seconds have elapsed. So in interval, we call it interval because it is a range of values. If I say, what is the temperature now? You might say 32 degrees or 31. This is just an indication. It could be a little bit above or a little bit below. So there is what we are going to learn about it, boundary values. When we say that it is 1:53, that means it's between 1:52 and 1:54. It says 1:53. That's generally what we do. So those kind of numbers, we call them interval. If it remains at the level of interval and it does not have a meaningful zero, then it is interval level. Remember, nominal, name, not more than name. Ordinal, order, not more than order. Not more than order means you can add and subtract. Interval, interval, not more than interval. Not more than interval means there is no meaningful zero. I will give example. Can somebody tell us what was your time for the first class? Anybody? First class to me. 11. You had a class at 11. And what time was this class? What time is this class? At what time did we start? 1:15. Which of the two classes was before? 11 or 1:15? Okay, how can that be? Which one is bigger, 11 or 1:15? 11 is bigger, right? So why are we saying 1:15? Okay, data from where? Just say from where? From what time? From what point? From 12, right? Our 11 was from midnight. Our 1:15 is from 12. That means we are assuming that noon is 0. Okay? That 0 is just an indication. It's not a meaningful 0. You understand what I'm saying? In my country, we don't use 1:15, 3. We just use like 13, 15, 15, 15, like that. We don't consider noon as another beginning. But does that mean that midnight is the right beginning? No. Nobody knows the beginning of time, right? Anybody knows the beginning of time? You just find some point. He said today is 2021. From where? When Jesus was born. Right? The Bible said at the beginning there was the Word, and the Word was God. But we don't know when was that beginning. So there's no beginning, no meaningful 0. But if I ask, how long have we been in this class? Now we can tell, right? And there will be a beginning and an end. We have been in this class probably for 30 minutes or 31 minutes. Do we understand what I'm saying? There is a time for like, when did we start? When is your next flight? What time are you going home? When will you finish? That time is interval. How long will you take to do that job? That one is ratio. But how long have you been doing it? I've not started. That means 0. And that 0 is purely 0. So just with time, we can have time in terms of interval and time in terms of ratio, because there is a 0. How much money do you have? That is ratio, because you can have nothing. Nothing does not mean you have, and you are not telling people you don't have. Nothing, 0, 0. Length, weight, they are all ratio. There is 0 pound. 0 pound means 0. But when we say 0 degree Fahrenheit, it doesn't mean no temperature, no heat. Right? Some people say I have temperature, like 100. So, but when we say 0 degree Fahrenheit, it doesn't mean absence of heat. In my country, we use Celsius, not Fahrenheit. So, but I used to know that 0 degree Celsius is freezing, like it will freeze. That's how we do freezing temperature. And I knew that nothing can survive at 0 degree Celsius. I did not know that some people have another unit of measuring. And then when it was 0 degree Celsius, they say it's 32 degrees. 32 degrees. And people go to school. Right? So 0 does not mean nothing. When I came to Pennsylvania, I could not believe that I can survive 40 degrees. I came in August, and in October, temperature was getting to 40 degrees. I was complaining. Somebody told me that in January, when 40 degrees, I feel like it's warmer. The man was close to his retirement. That is 15 years ago. So how can you tell me that the cold I'm feeling now, I will say it is warmer? until I got into January. Then I could understand what he meant. So the essence of it is that you might be feeling there is no heat, but there is, just that you don't feel it at itself. And IQ, I can't give you all the examples. You will see more when you are doing homework. IQ of 0 does not mean that person does not know that he exists. He has some knowledge. IQ is just 0 because it's just an indication. Okay, so we have 4 levels of measurement. Nominal, when it is only about name. Ordinal, name and order, and that's it. Interval, name, order, because we call it temperature. Name, order, but no meaningful 0. 0 does not mean nothing. For example, when we say it is 3 p.m. in Pennsylvania, somebody in California said it is noon. And it is the same time, right? That can hurt, but that's not the reason. It's because the initial point is not to be. That is the meaning of no meaningful 0. And the rest is ratio. So these are some examples. I would have already talked about it. Name is qualitative. We look at some variables here. We have names, which is qualitative and nominal. Zip code, qualitative, nominal. Departure time. This is the type of time that is interval, not ratio. Trip duration. Bus performance, for example. Good, very good. And this is qualitative and it is ordinal. So as I said before, when we want to do research and using a sample, the sample should be representative of the population, meaning that every member of the population has an equal chance to be part of that sample. Methods of obtaining random samples are called sampling techniques. There are essentially 4 sampling techniques. In a simple random sample, you randomly select individuals. For example, if I have a class of 20 students and I want to select 5 at random, I can write their name on small pieces of paper, fold it, mix, and choose 5. That's a simple answer. But if I have 2 million people, I can't write their name and do that. We will use a technique that is called a random number generator. A random number generator table is at the back of your book. A random number generator can be used to generate numbers. I want to do an example here. So suppose I have 1,000 individuals. To use a random number generator like the one on Excel, I can number all the individuals of my population from 1 to 1,000. That is a new name I'm giving them. And then randomly select 20 of them. To do that, I go to Excel and I click equal to. Then I will type random. We see here random between. Then 1, I want 20 to 20. 1, 20. And I get one number, which is 19. The individual number 19 is the first one I select randomly. If I want 20 of them, I can just replicate what I did there. I put here until I see plus. And I go to 20. So that means individual number 4 will be selected, number 8 will be selected, and so on. This is an example of simulation. We are going to discuss simulation if we have time. Simulation is a method of replicating a real-life situation on a computer using a computer program. So we did a simulation here, for example, of tossing a coin. I can say I want to toss a coin 20 times, and I do this. When it is odd, I say it is tail. When it is even, I say it is face. And this is an example of tossing a coin. How many even number do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if I want to check the randomness of this random number generator, if I get 18 even number out of 20, I will suspect that this is not a fair system. Do we get what I'm trying to say here? It's a sample, and from it, I can now infer that this software is not fair. But when will I feel like it's fair? Those are the type of questions we will be answering in chapter 7 and 8. We will be able to say that if it goes below 5 or above 80, above 15, we are going to doubt this system. We are going to learn to find those kind of boundaries, limit, from where we can no more trust a situation. Those are the type of things we learn in statistics. So this was a random number generator. You have one on your calculator. You have one on Excel. You have another one on your textbook. On your textbook, you have a bunch of random numbers on a table. And you can just point one. If you want just, let's say, 100 individual, you may just be looking at the last 2 digits. And some people have many methods of exploiting that table. In this class, we are not going to be using tables a lot. We are going to be using Excel and calculator. So I strongly recommend you to get a calculator. It will become more useful from chapter 6. But if you can get it now, you will get used to it as well. So this was an example of simple random sample. Systematic sampling consists of determining a number and then still numbering your population and pick the case individual. For example, I want to get 30 students randomly for a survey. And I go to Tovian and I count 1, 2, 3, 4, 5. I pick the 5th student. Then start again, 1, 2, 3, 4, 5, and pick the 5th student. That type of sampling is called systematic sampling. But sometimes none of these methods is the best. It depends on what research you are doing. I want to give an example of how systematic sampling can fail. That does not mean that systematic sampling is not a good method. Suppose I decide that I have a population and I want to select the 5th individual. Or let's say, let me just choose the 4th individual. In this family, a couple has 2 children, and a boy and a girl. So they have the tendency of moving like this, the wife and the husband. Let's say they are coming out of the church. People are very orderly when they go to church. So now I want to select the 4th individual to give the survey of who manages the finances of a house. We want to select the 4th individual. And we count 1, 2, 3, 4. And we pick this one. 1, 2, 3, 4. We pick this one. 1, 2, 3, 4. This is who we are picking. Yeah, we like to manage money. So now when you do the survey at the end, you feel like, wow, this is a random sample and about 90% of individuals in our sample are in favor of men managing the finance of the house. You see what is happening? So when you know individuals, like we know human beings, you will feel like, well, something is wrong with what I'm doing. But if you are dealing with bees, or maybe if you are dealing with trees, or you are dealing with things you don't know, and there is a pattern that you are not aware of in those individuals that are not humans, you might get that. So, in stratified sampling, you subdivide your population into groups that are called strata, which are generally social. For example, if we want to decide whether the school should continue to be face-to-face or online, now we may not just ask students, we should also consult faculty, we can consult the administration, and what about the parents? So we will subdivide the population into strata, and within each strata we will take a portion, just like I said when we were talking about apples. You might want to take apples a little bit everywhere and pick the small part of the sample you want to make. So that is called stratified sampling, dividing into small groups, and within each group, randomly select a portion of your sample. The last one is cluster sampling. In cluster sampling, the population is divided into clusters, and one or more clusters are randomly selected, and every member of the cluster is used. So the main difference between strata and clusters is that random members are selected from each strata. Clusters are randomly selected, and every member of the cluster is used. So when you will have homework or take-home problems, and you will be asked which method is appropriate, think about it. If you see that a group is selected, and every member of the group, that was every member, then that is a cluster. For strata, there are always many strata. And random samples are taken from each strata, not every member of the strata. Random samples are taken from each strata. There are also what we call convenient sampling. For example, I might just go to the registrar and get a list of students and do my research with it. Or I cannot use the student in this class. If I want to study eye color and I use the student in this class, it's a random sample because you came here regardless of what eye color you have. In my previous class, all of them, about 80 of them, all are female. I just realized that, how did that happen? The world is changing. Before we were looking for females into classes. What to do? Men should start their own revolution, wanting to become like female. What about that? Because from the moment women started to become like men, they are taking over everything. So maybe men should start thinking about becoming like women. I don't see that. I've been asking myself that question. Why are men not trying to become like women? And instead, when women want to take their place, they just shift and give it to women. Those are observations. After we can do research about that. Okay? So you make an observation and you begin to do research. We are going to learn in the next section about observational research and experimental research. You observe first and then. Should we just do that? Or should we keep it for next Thursday? Should we just do that? Yes or no? One answer is enough. Who speak louder for everybody? Next Thursday. That's my own democracy. If there is one that is for it, everybody goes. Okay, you can go over the PowerPoint. It is just about, it's observational when you don't do anything, you just observe. Experimental when you are the one that is making the result. For example, I can give you coffee. This group, I give you coffee. That group, I don't give you coffee. After 1 hour, I count number of people that will sleep during the call. That's experimental. Okay, guys. Let me quickly take attendance. I told you this class, there will be attendance, right? I don't take it every day. And if you don't want to be marked red, you just need to send me an email ahead of time, not during the class. I'm looking for where attendance is. Okay. Holly? Holly? Hello? Okay. Mark? Mark?
I'm here on Zoom.
Okay, let me know, please. Rebecca? Mary?
Here, I'm on Zoom.
Rachel? Hunter? Jacob? Megan? Logan? Kendra? Amaya? Tyler? Correct me if I read it wrong, please. Joseph? Sydney? And Mahin? Okay. It's not always easy for me to read those names. All is new, you know. If I start giving you my people's name, you might not even be able to repeat it. Okay, on Thursday we will continue with the last section. But you may be able to do your homework. If you have any question, please don't hesitate, send me an email.